Here I'll discuss three different problems which I hope will help you in understanding the concepts in physics more clearly and will help you to solve the problems. So the first problem is about the loss of energy when the charges are redistributed in capacitors. For example, you have a capacitor which is already charged, and then it goes, there is another capacitor. So suppose this is initially charged, and then suppose this is initially charged, and then there is a switch, and then you just connect this so that the charges will move on to this capacitor. Then you will find some questions in which it is said that there is a loss of energy when the charges on this capacitor 1 are redistributed into capacitor 2. So then the question is where this energy goes, because energy is conserved. So what will happen to the energy which is lost when the redistribution of charges take place? So then sometimes it is mentioned that it goes as heat, but exactly how it goes as heat? So it is not the heat in these conductors, like, we find the resistance gets heated, so it is not that heat. This is what I want to clarify. What exactly happens, you can understand it by taking the example of gravitational, for example, if you took a U-tube, this is a U-tube, and suppose you are having a liquid in this, and this you are having, let us say from here, this is filled up to H. Suppose there is a valve, here. So initially you fill this, so it is like charging this capacitor. Now you just open this valve. What will happen is the water will rush here. Then you will have a scenario where in both you will have the water up to this. So this is, let us say, H prime. So the height H becomes H prime because the water is now, because we know that it finds the same level. So it is like these two arriving with the same potential. It is the same. So what happens is this portion of water actually will lose its potential energy, and then it comes here, somewhere here. I assume that it is somewhere here. So that means basically what's happening, the potential energy, so this actually will get kinetic energy, it will move up. Actually you will find, if there is no friction, you will find once you open the valve, then this actually you will have oscillations in U-tube. Actually there will be oscillations in U-tube. So that means this water gets kinetic energy. Similarly, the electrons, when they move from here to here, they gain kinetic energy. And that kinetic energy will remain with them, and this is ultimately they will reach here. Assume that there is no resistance, that means there is no loss of energy during the flow. During the flow in the wire. So we are taking a conductor which is theoretically no resistance. So the energy is not lost here. Often somewhere, some places it is mentioned it is lost here. No, it is not lost. It is lost, of course, if there is resistance, but we take a theoretical case, a superconductor which has no resistance, so no energy is lost. So ultimately this energy which is lost will be there in the form of a kinetic energy of the electrons. The kinetic energy, of course, again here it is nothing but the temperature of this. So here we can say it gets heated up. The capacitor plates will get heated up, because we know that the temperature and the molecular speed are related. The molecular speed or electron speed, they are related. So that is how the energy is lost. This example of the analogy of the gravitational system will help you to understand how energy is lost when the charge is redistributed between two capacitors. It is exactly similar to this case. So the next problem which I would like to discuss is, the question is, there is a hollow insulated conduction sphere is given a positive charge 10 microcoulombs. So there is a charge which is given 10 microcoulombs. Then the question is, what will be the electric field at the center of the sphere if its radius is 2 meters? So the radius is 2 meters. What is the electric field at the center? This is the question. So this question basically is only to trick the students, because we know that if there is a conducting sphere, then the electric field, the potential is constant, the electric field is 0. So you will see this examiner is, the question is only to trick the students, but this 10 microcoulomb and 2 meter actually doesn't matter. It may be 100 microcoulombs and 100 meters, still the answer is the same. So these numbers, it is only to confuse the student. So that's why it's important that you know the concept. If you know the concept, then you can straight away answer that electric field is 0 without having to do any work. Okay. So it is the concept. Then the next question, this is the second question. And the third question, which problem that I would like to show is, a point Q lies on the perpendicular bisector. Perpendicular bisector. There is this same, and this is R. This dipole is P. Okay. Now it is actually the question is, what is the field? The electric field on Q. So we know that the electric field Q is nothing but it is P by P and R cube. Okay, this is the electric field. If you remember the formula, if you remember the formula, then fine. But even if you don't remember the formula, if you know that the field is nothing but force, it will be having the R square dependence, and you should know that P is the charge into the distance. So using this knowledge that the force, simply the question is to find out the electric field is proportional to what. So using this concept that the force has to be, the field has to be 1 over R square, and the dipole moment is the charge into radius, then we can simply say that it should be proportional to P by R cube. So the knowledge of the dimensions helps you to answer even if you do not remember the formula. So this aspect I feel the student should keep in mind when studying the subject. So if you like this type of problems to be discussed, please subscribe and set for your notifications so that I can add more of these videos in different topics of physics relevant to grade 11 and 12. I hope this helps you. Good luck.